Next, what is the current distribution in the antenna? What is the current distribution in the antenna? Current distribution. Okay, so when current distribution in the antenna, generally there are many antennas. Okay, but once if I take very basic antenna, that is lambda by 2 antenna. Okay, say when I take lambda by 2 antenna, okay, this is total length of the antenna. Okay, total length of the antenna. The total length is lambda by 4. Okay, I'll erase this because I have to write something else here. So the total length of the antenna is lambda by 2. Then half portion is lambda by 4. This is lambda by 4. And this is lambda by 4. Okay. Now here you will connect your source. Okay, AC source. This is very important. Only AC source you have to connect. AC source. Okay, once if you connect AC source, okay, actually the AC source value is actually always time varying, because always time varying. So once if it is time varying means if you take simple AC signal, okay, the value may be 0 or maximum or negative, but this signal is going to the open line. Okay, it is not going to the closed line, it is going to the open line. So once if you give, please mute your mic, others. Once if you give some signal, the 2 AC signal to the wire, let it be AC or DC, but you know one thing, once if you are at open circuit, say when the signal comes here, the signal will come happily from here to here, here like this. Once it comes here, it sees open circuit. Similarly, once if some signal comes here, similarly it sees open circuit. So what is happening? See, when the signal is moving from here to here, when this is happily moving, but here it is open circuit. You know one thing, once open circuit is there, whatever may be your input, let it be AC or DC, the current value there is 0. Current value there is 0. So then where the current value will be maximum, where the current value, you know one thing, the current is maximum after lambda by 4 distance. As per the transmission line concept, if something is minimum here, that will become maximum here. So voltage is minimum here, then it will become maximum here. Why? Because you have traveled lambda by 4 distance. If something is maximum here, then definitely after lambda by 4 distance, that will become minimum, because you know that once if you travel lambda by 4 distance on the transmission line, the maxima and minima is getting interchanged, similar to the how the open circuit and short circuit is getting interchanged. So what I'm telling, so exactly at this point, the current is 0. The current may be maximum here, the current may become maximum. Okay, I do not know, because at any point of time my AC can be anything, but current may become maximum here. So the current distribution goes like this. Okay, this is the current distribution for lambda by 2 line. Okay, lambda by 2 antenna, lambda by 2 antenna. Similarly, if I draw the current distribution for other antennas, say I can take lambda by 4 antenna also. Sorry, this is lambda. Once if it is lambda, then what is the current distribution? Okay, now this is minimum. Then after lambda by 2, minimum will become again minimum, because every lambda by 2, the characteristic remains same. So this is lambda by 2. The total length is actually lambda. Here total length is lambda by 2. Here total length is lambda. If it is lambda, half portion is lambda by 2. Then if it is minimum here, then here also minimum. And again, this will become like this. Okay, so this is the current distribution in the lambda line. So once if the line is like this, if length is 1.5 lambda, if length is 1.5 lambda, then the current distribution goes like this. This is the current distribution for 1.5 lambda, and this is the current distribution for 2 lambda. And this is for 2 lambda, and this is for lambda by 4 line. Once if we take lambda by 4 line, only you will get half portion of lambda by 2 antenna. Once if you have only half portion, you will get half current distribution. So you'll get current distribution like this for lambda by 4 antenna, for lambda by 4 antenna. Okay, so now this is the simply current distribution. Whatever may be the length of the antenna, lambda by 2 or lambda by 4, almost the current signal is of the nature of sinusoidal, maybe half sinusoidal or full or 1.5 like that. So simply the current distribution nature is sinusoidal. So what is important in the exam, they'll ask what is the current distribution nature in lambda by 2 antenna. So that is sinusoidal. So this is what sinusoidal current distribution. Sinusoidal current distribution. Sinusoidal current distribution. Okay, the next question arises. There is a one more antenna is called as infinitesimal small antenna. Okay, infinitesimal small antenna. So what is the another antenna? So the antenna is name is Hertzian dipole. Hertzian dipole or infinitesimal small antenna. Small antenna. Is there any other name for this antenna? Very, very small antenna, infinitesimal small antenna. Yes, sir. Why we take this Hertzian dipole or infinitesimal small antenna? This is actually the practical reference antenna for all other antenna. Okay, this is actually the practical reference because we are having isotropic antenna, but because that is ideal, that is not existing properly. But we are having another antenna that is Hertzian dipole or infinitesimal small antenna. This is the practical antenna that is actually used to discuss all other practical antenna. So what is the meaning of this one? When your length of the antenna is much less compared to wavelength of the signal. Okay, if you know what is wavelength of, you know what is your operating frequency, then you know what is the wavelength for that frequency. But once if you choose your length of the antenna is much smaller than lambda, okay, then that is called as Hertzian dipole or infinitesimal small antenna. So please always, whenever it is lambda by 2 or lambda by, it's always related with lambda only. So once if you discuss about length is always related with lambda, because what is important, frequency of operation is important, that will decide lambda, then you have to compare the length. So once if you choose physical length of the antenna that is very less compared to lambda, then that is called as Hertzian dipole or infinitesimal small dipole. So you know what is very less. At least L should be less than lambda by 10. At least. What I'm telling? At least L should be less than 10. Then can I take L divided by 20 also? What? It comes under Hertzian dipole. L divided by 20 also. L divided by 30 also it will come here. But if I choose other thing instead of 10, if I put 8, 4 like that, then it may not come here. It may go into other category. Because if instead of 10, if I put 4, then what will happen? That is similar to lambda by 4. And so that's why always what is very less. At least if you find out what is 10% of the maximum is lambda, the 10% of the maximum is this one. If that is still less than, okay, if your antenna length is still less than lambda by 10, if your antenna length is less than 10% of the wavelength, then that is called as Hertzian dipole or infinitesimal dipole. So like this, you will have many varieties, less than lambda by 20 or less than lambda by 40 like that. So then how to do the antenna analysis? Again, another important discussion here is, see, once if I have AC source, my length is very small length of the antenna, then I connect this antenna, connect my signal here, okay, to the small portion of the antenna. Then what is the current distribution? See what they are telling, when the antenna length is very small, what they are telling, the current distribution cannot be sinusoidal nature. The current distribution is uniform on the entire length because it is very less. Okay, it's simply like a point. So once if it is a point, then the current distribution, you cannot do any current distribution. The current distribution is simply linear. Okay, current distribution is linear or uniform. Current distribution is uniform. Current distribution is what? Uniform. What they are telling, as the length is very small, so there is no current distribution. The current is uniform everywhere. So the current distribution here is uniform. It's very important. Okay, for all other antenna, the current distribution is sinusoidal. For Hertzian dipole, we assume that the current distribution is uniform. But in reality, that is not uniform. But for discussion point of view, we used to assume that the current distribution